So I realized something today, that we only have 4 labs left in this class, which is kind of crazy. And I've been working on putting together the little packets that, we're going to actually have you guys like pick up, so that way we can physically build some things and have some stuff that you guys can kind of keep. And I'll show you guys that in just a little bit. But yeah, so I was thinking Thanksgiving was the week, like the 19th, 20th of this month. No, Thanksgiving is the last week. And I was thinking I had more time to kind of give, get these materials out. But we really have like 2 weeks until today to get these materials to you. So that's going to be something that we really need to kind of focus on, and doing that. And so, and I'm not 100% sure on how, what the best way for us to get that stuff out, to you guys. But I think probably, what I'd like to do is, as much as you can, if you can come by and pick these things up, that is going to be the easiest thing, because mailing these things or trying to get them out, in that way, it's going to be a little bit tough. There is Mr. Williams is going up north of Sacramento next week. I think on Thursday, I think he's going to be up near Sacramento area. So if you guys are up kind of in that area, he can grab some materials and give them to you. Just kind of meet you on the side of the freeway and get you the materials if you're up that far. But we'll, if you, that's you, Emily. Okay. So if you can't, I think that's probably the best way. If you cannot come by because you're too far away from Fresno State, and you can't come pick up the materials, shoot me an email, let me know where you are at. Shoot me an email, let me know where you're at, and then I can work on getting those things out. That way I know how many people I need to try to get these things to, whether that's delivering them or do that. Okay, you live in Galt. Okay. And then we can get that stuff scheduled out, so that way we can get the materials to you. If we have to mail some of them, we can do that, but that can get pretty expensive because some of the stuff is pretty big. In fact, I'm going to show you guys a little bit of what we have and what I've been working on with this stuff. So we've got a little electrical board. I'm blocking my view so I can't see it. So we've got boxes that are in here, and I kind of did it up a little bit fancier, and this is backwards, I realize, but that's the little FS logo on there. I think it's kind of cool we did that with the laser. So we've got those boxes, those things are together. I've got 2 different designs, and I've just did half and half because it was a little bit easier. So we've got some that's got the bulldog on it. We've got some that has the FS logo, but otherwise we have, the boxes that are on there. And then with that, so we've got those boxes, and then I've got equipment. It's all bagged up in little baggies here. So you'll grab a board, you'll grab a bag, and they're all kind of set, together for the electrical stuff. And then for the plumbing, I've got a bag for the plumbing materials. So all the plumbing materials are in there. We're going to do PVC because that's what we can do. And I think I have a way that we can kind of glue it, because we don't have glue in these bags. We don't really use that much, but I saw something online from another ag teacher that said that they can use like nail polish remover or something like that to glue the pipes together. But in either case, we did do a mock-up where we just kind of like, where we put the project together and just pushed it on by hand. We put it on, we're going to make a little sprinkler. Similar to what we would do before, but we would do copper pipe and we would do black pipe. The tooling for that is just, it's kind of tough. So we're not going to be able to, to do those things, but you guys will have a sprinkler that, we'll be able to work with. And I'm trying to figure out a way that maybe a material that you have, most of you are probably going to have at your house, that we can use to glue them together. But even not gluing it together, just pushing these pieces together, and we hooked it up to a hose, and the sprinkler works just fine, and it doesn't leak at all because it's not building up pressure because there's a sprinkler head on it. So we'll do those. Those 2 things are going to be the last week. We'll have those, and so we'll pick those materials up just all at once, and we'll grab those things. What was I going to say? So I'm going to look into that, and you know, when we do that, what we'll do is we'll just build the projects together. So we will, you know, in lab, you know, we'll have the materials for the electrical, and I'll show you guys that whole process. And then obviously those are things that you guys are going to keep. I'm not going to be able to like grade them necessarily like I would normally, you know, but we'll kind of, you know, we're going to look at it, and you're going to do it. It's more for you guys to have something that, you know, something physical. And so hopefully it'll be cool. I'm really kind of excited about the electrical boards because I think they turned out pretty nice. I kind of like them. And it'd be nice to have this as something that we do every year, but they're pretty expensive. They're not cheap, but you guys paid a fee, and I wanted to give you something that you can have. So when you get done with it, you'll have this little electrical board that, you know, will work. Some of the things are pre-wired, they're pre-cut, everything's kind of there. The only things that you're going to need are going to be Phillips head screwdriver, and then a pair of pliers, which those are two pretty common tools if, you know, you have those, or if you can get a hold of those. If you can't, when you come to pick up the stuff, just let me know, and I can let you borrow some of the tools that we have in the shop. I just need to make sure that I get those tools back at some point. So if you don't have that stuff, just let me know when you pick that stuff up, or if you're not picking it up and we need to kind of mail it, let me know, and we can, you know, I can maybe just kind of throw some of those things in there. Like I said, the important thing is that we just get those stuff back. So they're not, the tools aren't going to be for you to keep. But most people, I feel like you have that stuff at home, or you may have access to, you know, some of that stuff. So, and that should be pretty fun. So that's going to be the last, you know, two labs. Really what we're going to be dealing with today, and I feel like my internet's about ready to cut out. My camera looks like it's lagging a little bit. So anyway, before I move on, shoot me an email if you can't come by, if you're too far away, and let me know. If you can pick it up, I'm going to be here tomorrow. If you are available tomorrow, I'm going to be here. You can come pick it up. It's going to be in room 106. I'll send out an announcement. And they're all together. The boards, the bags, they're on top of that. You grab a bag with an E, you grab a bag with the P, you grab your board, and then there'll be some plumbing, some PVC pipe that we can do. And the PVC pipe, you can cut PVC pipe with just about anything. So we'll show you some of those things, and you guys will have tools that you can cut, you know, PVC pipe with. So that won't be an issue either. So it's going to be in room 106. I'm going to be here pretty much all day tomorrow, probably till 3. If you want, and you want to come pick those things up, I have, you know, the stuff ready. I've got to get a couple more materials, but you can do that. And then pretty much all next week, I'm typically here, you know, about 9 o'clock, and then I'm here until about 5. And so you guys can come by and you can pick them up. I do have some classes that I run, but, you know, I run them, you know, if I'm typically in my office or whatever. But, you know, 106 will be, you know, unlocked. You know, you can find me, you can find Mr. Williams, and we can get those materials. The only thing I ask is if you are going to come, either shoot me a text message. You guys, that should be on that first announcement. I have my number, or, you know, shoot me an email and let me know when you're planning on coming. So that way I have an idea and I don't try to take off right before you're going to come. So, you know, just shoot me an email, let me know. And then we can do that. Yeah, you know what, Eric, that's not a bad idea. You know, if you guys are in certain locations that, you know, kind of pick up materials for a couple other people, that actually would probably help out quite a bit. So, but I think it's going to be pretty cool. I'm kind of excited about it. And I know it's, you know, taken me a little bit to kind of get these things in, you know, get them together and get them situated. But, you know, I wanted to make sure we got something that was kind of cool. I didn't want to just kind of throw something together, right? I wanted to think about it and have something that was kind of, you know, kind of a little bit unique. So anyway, any questions with that right now?
Sorry, McKenna, I came in a little late. What's like the best days and times for you specifically?
Anytime. I am here, like I said, between 9 and 5, Monday through Friday, pretty much every single day, Monday through Friday. So anytime for me is good. I'm here. I don't do anything. I do stuff, but I'm here on campus. I'm not, you know, I'm not coming in and stuff. So, you know, it's completely flexible, up to you guys. Whatever's convenient for you, just come by. Just shoot me an email so that way I know you're coming and roughly about the time. Because if I have to pick up my kids or something like that, I don't want to be like, oh, I got to go early, and then you come at like 4:30 and then I'm not here, if that makes sense.
Okay, sounds good. Thank you.
Cool. That sounds great. I like how you guys are working together. I appreciate that. That definitely helps me out because that's the one thing I've been stressing out a little bit is how to, get these materials to you. But yeah, we can work that out. We can do that. All right. So we're going to kind of, jump into some woodworking. And last semester, I did some videos of some of the stuff that we have made, and I'm going to share the screen right now. That's not the one I want. Some of the stuff here, that we did. I'm not going to show you the video right now, but next week. I'm going to post that video up. It's kind of like a 2-part video. There's also some safety stuff with woodworking tools. There's a video we made, and rather than kind of recreating the wheel and doing that kind of stuff, the woodworking it's a little bit tough. It's a little bit different, but it is a full build. It is the full thing. It shows you the stuff. It shows you the tools. So we did the little bar stool build, and I'm going to kind of show you. This is the little sheet. You guys have access to this, but this is. Let me see if I can zoom out maybe a little bit. So this is, the bar stool that we would have. We have different colors to kind of designate the different parts and whatnot. But the bar stool, it's a pretty cool little project, that we put together. We have this, and typically what we do is we give kids options, with these things. I didn't make a video on the step stool stuff, but these are the step stools that we would typically build in this class. And one thing, I kind of thought about, doing, something with this and trying to make it a little bit different. Because it's hard. Woodworking, you need to have the tools, and that's just something that not everybody has. And so it's a little bit tough. So the videos are going to have like a little quiz that's going to be, assigned to that. So you watch the videos, there's questions that are going to be on that quiz. You guys will be able to take that quiz as many times as you want, right? So you can take it, it's not like a true quiz. Okay. So you'll be able to take it as many times as you want. So you will watch that video. We'll put that together. But what I was thinking about doing was having you guys design one of these things. You could do both of them if you wanted, but designing it on Google SketchUp. But it is a tougher project than the stuff that we did at the beginning of the semester. So what I decided to do was give you guys an extra credit opportunity of up to 50 points kind of in the lab section stuff. If you want to design either the bar stool or the step stool, and you want to basically take these things where you're taking the dimensions, you're putting these things in there, and kind of working with this stuff and building these things in Google SketchUp or any other 3-dimensional design program. That's up to you. But we've kind of worked with Google SketchUp a little bit and doing that. Now it is going to be a tough project. That's why I decided not to have you guys do this, because it really is very involved. But if you want to get some extra credit, you want to try that, we can work on those things. Next week in lab, because you'll kind of have the lab, videos that you can kind of watch in your own time and do the quiz and stuff. So next week in lab, if you guys are interested and you want to kind of work on this, or if you're having questions or you're having problems on the Google SketchUp and you want to kind of work on these things to try to get that extra credit, I can help you, next week. I can really help you at any time, but we'll definitely designate that time next week where I can kind of work with you guys and maybe show you some things, on this, so that way you can complete it. So gives you some time. If you decide you want to try to do one of these things, it gives you some time to kind of start working on it, start designing it, maybe running into some issues, and then build up some questions. So that way next week, I can kind of help answer those questions for you. So it's an extra credit opportunity for you to do that. Next week, there'll be, a couple videos, that you'll watch that's going to deal with, building. It's going to deal with the safety stuff. It's really everything, that, we essentially would be going through in class. But rather than showing you that video, I figured we can just, you guys can kind of watch that on your own time. But one thing I'm going to do today is I'm going to go through a couple PowerPoints. They're not too long, but rather than doing a video recording, I figured it'd make more sense to just do this in person with these ones, since I actually didn't have a video on these ones anyway. So a couple things about wood, and some of those videos that I'm going to show you, they're going to show you a couple tips and tricks that, you can use when you're working with wood. Some people don't necessarily think about, these types of things and whatnot. So we'll just kind of go through these things and do this. So hopefully you guys know that wood comes from a tree. It is, an object that, does kind of vary. And so sometimes wood, and you might see it like on some of these pieces here. You might see the grain structure. You might see kind of a discoloration here versus right here. That all has to do with like the sapwood, the heartwood, where that's coming from out in the tree, how close the grain is on these things together. Sometimes you get imperfections and you get different things like knots in the wood. Knots are not necessarily a bad thing, but if they're placed in the wrong spot, they could be. Sometimes you get nice, unique. I don't know if you can see these kind of brown kind of dots in there. That's just like from little branches and stuff that were on that wood that just kind of grows. It just kind of grows with it. And so you get some really cool kind of, different designs and different things, with wood. No two pieces are going to be the same because it is growing from a tree. Obviously, every year the tree grows, it gets a new ring. You basically have on the outside, you have the phloem. Well, you got the bark, right? But then you got the phloem. That's where the nutrients are, coming up from the roots. And then what happens is that phloem dies off. It turns into the xylem, which is going to suck up that water. And then, that tree is just going to grow every year. So every ring is a new year, right? And if it, depending on how fast that tree grows, how slow it grows, is going to determine how big those rings are apart, how strong that material is going to be. Faster growing trees typically are a little bit weaker. Typically what we do in class, we use pine wood because pine is, it's cheap, it's easy to work with. You can spend you can spend a lot of money on like hardwoods and different things like that, but it's going to get expensive. So like in an ag mech class where you're learning how to do this stuff, we typically don't use with any hardwoods and stuff. But pine is going to do the same thing. You're going to work with the tools. It's very easy to work with and all that kind of stuff. We grade lumber in kind of two different categories. If we're talking about hardwoods, we're classifying into the grades that they are free of knots. Okay, so if I go bring this piece back up right here, you'll see there's some knots in there. Pine wood, we don't really grade this that way, but in hardwoods we do. If you look at like the little picture that we have on this PowerPoint here, this is probably like maybe it looks like a red oak, maybe. This one, there's no knots in that picture right there, right? If that was a big board, the more space that it takes up, the more expensive it's going to be. But you're paying a premium for those things. On the pine boards that we get, there's going to be knots, there's going to be stuff in there. But pine wood's not a hardwood, it's a softwood, right? And that's what makes it easier to work with and easier to kind of manage. Softwoods like pines, we classify into either select, that's when boards are going to be seen, common, that's going to be for construction stuff, and then dimensions is basically when we need strength. Okay, so typically you see common and dimensions going to be like in the walls and stuff like that, or the select boards, that's going to be the boards that you have, that's going to be on your guys' electrical boards. This is going to be select boards, they're going to be seen. And so, they may not be free of knots. It's tough, right? Knots are formed by branches in the trees. And so the grain goes in different directions. And like I said, sometimes it can affect a project. Sometimes it doesn't affect it at all. And like I said, I'm pretty sure in that video, it shows you a demonstration of what happens, with knots and where there would be issues there. So you guys will see that stuff next week. One thing that we do with boards is when we cut these things down from a tree, because the part that we're actually using, that xylem, that's sucking that water up, right, from, the roots. What happens when we cut down a tree is that tree is going to be what we call green. So we have to cure this lumber. Before we actually start working with it. Okay, if we don't cure that wood, right, and that basically curing is letting that stuff dry out, the boards are going to warp, they're going to twist, they're going to crack. You're going to have a lot of issues with these things. Ideally, we want to get this wood down to about 15 to 8% moisture content. Okay, for every thickness of board, okay, this is a little 1-inch board that we have here. You need to cure that for 1 year. Okay. And you can see kind of that little picture. They kind of lay them out. They might kind of cover these things so that way they don't get rained on, but they put spacers in between there and then they just let it cure in the air naturally. Okay. So for every inch of thickness, that needs to sit out for 1 year. So you can imagine you cut down a tree, you can't start making stuff with it because you want that moisture content to get down. You want it to be 8 to 15% because that's typically the moisture content that we have like in a room. So if you're building a piece of furniture, that's the kind of moisture content you're going to have in the air. And so it's not going to kind of absorb that. If you are in a higher moisture content area, that stuff could absorb that if you dry it down lower, and you're going to get kind of twisting, warping, and cracking. And wood will do that over time. So if you work with a piece of green wood and you build a project, 6 months down that road, that project may be kind of tweaked. If it's a chair, it may not be level. It may not be stable because stuff is going to move on this wood. So it's really important that we get that down to the right percentage there on moisture. If it's green, it could have 120 to 130% moisture. It's going to be retaining more moisture. Sometimes I've seen branches before get cut down and water pours out of them because it's a little old mulberry tree we had. And it's kind of crazy to see water just pouring out of it, but it can do that, right? It can be that green to where it's there. You'll know if a board is green because if you ever pick it up, if you've gone to like Home Depot or Lowe's and you've picked up boards, even like 2x4s typically, you might have one 2x4 that's really light, the same size 2x4, same length and everything. It might be 5 times, 10 times heavier than the one that is dried out. And that's just all the moisture content that's in there. So if you're ever grabbing boards and you're doing that from Home Depot or Lowe's, if it's real heavy, you might want to shy away from that because it's a good chance that that board is green and it's not going to work very well for you if you're working with it.
I had a quick question.
Yeah, go ahead.
Is there any way that you could like dry the wood to make the process faster?
That's what the next slide's going to go over. Yeah, good question. Okay, so yeah, we can cure these things in a kiln, which is basically a giant oven, like you can see that in picture right there. They typically are going to space these things out. And what they'll do is they'll let these things, they put these things in the oven and they draw out that moisture really quickly. And that's typically what Home Depot and Lowe's is going to do. They may set it out for a little while, but then they're going to bring it into that kiln and they're going to basically, cook it in an oven. And that's going to draw that moisture out. So that process is going to be speed up. I'm not 100% sure on how long they have to do that, but it might be like a week or it might be a day. I'm not 100% sure on that. But what you do find, if you go to like a Lowe's or a Home Depot, they cure lumber like this a lot, and they're doing a lot of lumber. And so the process, the quicker you draw that moisture out, the more warping, the more cracking, the more cupping. Cupping is like when it goes like from, I don't have a board here, but this board wouldn't be straight. It would actually be bowed right in the middle there. And it would be bowed up or bowed down. Really depends on what part of the tree that we cut it from, how that does that. But you do get that with boards. And Home Depot and Lowe's, you typically do get that. So if you've ever looked at somebody, I guarantee you guys have all seen this, seen somebody at like Home Depot or Lowe's, and they're taking a 2x4 and they're taking it on its side and they're looking down that line. They're checking for any kind of warping. They're checking for any kind of twisting that board has. And when you do it in the kiln, you're going to get a lot of that. And so Home Depot and Lowe's, you get that. A good like lumber mill, typically you might spend a little bit more, but they're going to go through a slower process of that curing. And they're not going to draw that moisture out quickly, which is going to help make sure that those boards don't warp, they don't crack, and they're not doing that. So those are some things you got to look at when you're purchasing boards. And it's tough. As an ag mech teacher, I had one year when I was in Tulare, I had 120 students that were in my Mech Ag 1 classes. So that's 120 students, 120 boards that I had to buy for those students. And to go through and to select all those things, it's tough to do that. And some of those things, we would get a little bit of warping, a little cracking, but when we cut them in different pieces, sometimes that doesn't make a big difference. If it's one long piece that you're leaving and you're not cutting it and you've got a twist in this or you got a warp in it, that could cause a big issue. But when you're cutting it up into smaller pieces, sometimes it makes life a little bit easier and you can kind of get away with some of those things. You might have seen some boards that look a little bit different. That's because there are different ways that we can saw that board. The most common one is going to be a plain sawn. Quarter sawn is also going to be another way. I'll show you guys some pictures, of these things, I think on the next couple of slides. But the way we saw that wood is going to change the strength and, kind of the overall look of that wood. And a lot of that has to do with, the process, like, how quickly does the sawmill want to get it done? What type of wood is it? Is it a hardwood or is it a pine wood? Typically pine woods, they're going to be plain sawn because it's quick, it's easy. But you don't necessarily get the most strength out of those ones. Rift sawn is going to be the most expensive. You don't see that very often. You do see quarter sawn wood. Typically in hardwoods, you'll see that. But that's kind of part of the process. It's a little bit more, involved. It's a little bit, tougher to kind of, process that stuff. So that's why that wood's going to be a little bit more expensive, beyond the means that there's just like oak wood is just not as plentiful as maybe some other ones, or even like mahogany or different things like that. There's a lot of different woods that you can get, that are there. A lot of companies like sawmills and things like that, when they are processing these things, they have computers that are like determining, they have like a little camera that looks at the log and it determines the best cuts and how we can get the best boards out of those things. So, but I got a buddy of mine who runs a sawmill here, out of Fresno area. And they just do it all manually. They put it on. It's a little saw that they just basically, it uses hydraulics. It pushes forward, but they eyeball all of that stuff. There's not any like computer components that are going through. And so some people do some of those things. So here's kind of an example, and this is why plane saw is the easiest, right? And this is typically what my buddy does at his sawmill. Is he puts this board, on the mill. And the blade essentially is just going to run across, and they're just going to make a cut. They lower it, they make another cut, they lower it, they make another cut, right? And then just go through that board all the way through. Typically what you're going to see with these things is, a grain that kind of looks like this. You'll notice, especially as you get more towards like the center of the tree, you're going to see like these, the grain pattern is not going to be very tight. Probably a good example of that right here. You can see how far apart that grain is in those structures there. Like I said, hardwoods, typically we do like a quarter sawn right here. And the quarter sawn, you notice we kind of cut it here, we cut it there. And then what we're doing is on these rings here, we are going against that grain, or we're going, each ring is kind of next to each other. And you'll notice the pattern that we get with this quarter sawn, where that grain pattern is a little bit closer to each other. That's going to give you a little bit more strength on there. Obviously, it's a little bit more of a process to go through. Again, that's why that adds that price to it. But we call it quarter sawn, right? Because we basically quarter that, and then we just cut those boards out. You'll notice we'll get different widths of these boards as we go through. Same thing with the plane sawn. We get different widths as well. These ones aren't necessarily like, perpendicular to the grain though. And that's where that rift saw kind of comes in. It's kind of like a quarter sawn, except you'll notice that there's, material. These things are going directly across that grain there. And that's going to give you the most strength. Typically on, better quality woods, higher quality woods, that's typically where you're going to do that because you want that strength, and people are willing to pay that premium for this process. There's also a lot of wasted material with this rift sawn stuff. Anything that doesn't have like that little rectangle there, that's just going to basically be turned to sawdust. So it's all stuff that we really can't use. And so that's kind of the most expensive, and you can kind of, hopefully kind of see why. But if you want that strength and you want that look, you're going to be willing to pay for that stuff. Like I said, most common you're going to see is plane sawn, just because it's easy, it's quick, and it'll do that. But if we have like quarter sawn wood or rift sawn wood, a computer will go through, it'll determine that stuff. Not all logs are going to be perfectly, symmetrical, from one side to the other. So they look at those. The one thing that you got to worry about with boards, so like this board is, we call it, it's a 1x12. So it's, it's about 12 inches wide. And you think about that, if you have one board that's 12 inches wide, that means that the tree that we cut from has to be at least 12 inches wide, right? And so some trees, they're not going to be that big. That's typically the biggest that you will get as far as width on wood. And if we want to put tables together or do things where we need large surfaces, we're either going to use like a plywood, or we're going to use, or we'll kind of join those pieces together to try to create one kind of smooth surface. Plywood is actually kind of interesting. The way that they do this is when they make plywood, they actually take like a blade the length of the board, and it basically spins the log and it cuts like one of the rings out. And then they just lay that ring out, or they lay that board out, and then they just laminate those things together. So they stack them on top of each other. If you get a chance, what I want you to do, and the next time you look at a piece of plywood, if you look at it and if you see some knots in that plywood, if you look over sometimes, a couple feet, you will actually see the same exact knot, because as it goes around this tree, right, it's making the circumference, it's cutting that out. And sometimes it wraps around it like twice, and you'll end up seeing that knot and it'll kind of duplicate. You'll see like an image that looks, the same. So look closely the next time you see a piece of plywood, and you'll see that's kind of a cool little deal. But that's how they process it, how they cut it to get that full length is there. Obviously, strength and all that kind of stuff. It's not like a solid piece of wood because they're gluing them together. So it's not something like this where this is just a solid piece. But if you wanted a board that's 2 feet wide, that tree would need to be 2 feet wide. My buddy actually that does the sawmill, he does big redwood trees. He cuts those things down. And we've done some tables. We've done a little winery bar for the winery out here. And we got some, what they call that live edge board. So it's like a good 2-inch thick piece of board. It's got like the bark and stuff that's on the outside. And those ones, it's a good solid piece. But, you end up paying a little bit more for those, obviously, because, they're not as prevalent as other things as far as that stuff goes. How we finish lumber, and this is when we talk about finishing, this is not necessarily finishing, like if you were working on it, but when you're buying lumber, you can either buy it as a rough cut. You might, that stuff, we're not like planing them down. So if you go through the sawmill, it's directly from the sawmill. It's how they cut it from the tree. And that's what you're getting as a rough cut lumber. Some people, I don't know if you've seen, but I've seen them on Facebook before where people are like, hey, 2x4s, back in, 1940s were bigger than the 2x4s that we have today. Well, that's because the 2x4 that they were working with back then was simply rough cut lumber. So we didn't actually plane it down where we're kind of smoothing that stuff up. You're going to have a real rough surface directly from the sawmill. The thickness of those are going to vary a little bit. We have boards that are surfaced on 2 sides where we basically take a blade and we cut it to kind of smooth it. So we might do, the surface of it, but we're not going to do the edge. So if we did surfaced on 2 sides, I'd take a blade and it would cut across here, and I'd blade that would cut on the backside, but I wouldn't hit my edges to get those things cut. The other ones that we have are S4S. Those are surfaced on 4 sides. So it's, both, the front sides and, the thin edges. All 4 of them are going to be basically surfaced down to where we get a little bit more exact dimensions there. And that's going to come into play, I think, on the next slide. We'll kind of talk about that. And then there's also sanded stuff. So they go through, they plane it, and then they take it through a sander and they sand it down, and it's really smooth. The more processing you go through, the more expensive that board is going to be, because there's more, man hours, there's more machine, there's, electricity and all that kind of stuff that you got to pay. S4S, that's the boards that we have here. They're surfaced. They're not a rough cut. That doesn't mean we don't need to sand them. It doesn't mean we don't need to kind of maybe clean them up a little bit, but they're going to be fairly smooth. They're going to be fairly, straightforward on their dimensions. The dimensions are not going to vary very much. They're pretty much going to, hold the same dimensions as opposed to a rough cut. So all 4, if it's just sanded, they're going to be the exact dimension, but the surfaced on 4 sides, they're pretty close, for the most part. So lumber sizes. Can somebody tell me how big a 2x4 is? Like how thick and how wide is a 2x4?
Two inches by 4 inches, right?
No, it's not.
No.
It's not. Why the heck do they call it a 2x4? It's
Is there-
actually 1.5 inches thick by 3.5 inches wide. And the reason that's labeled that is right here, because we surface these things on 4 sides, we actually lose a little bit of that thickness. And so they actually drop that thickness down. It's not that rough cut lumber like we used to have. When we rough cut it, we're kind of like, okay, yeah, it's going to be about 2 inches, about, 3 inches or 4 inches. And that's going to be pretty good. But when we surface these things, it actually makes them a little bit smaller. So that's why if you see some of the things, it's like, oh, like 2x4s are smaller. Well, that's because they're planed down. They're not rough cut lumber anymore. We're getting more of those exact dimensions. So they're going to be 1.5 inches by 3.5 inches. Why don't we call it 1.5 inches by 3.5? Because a 2x4 is just easier to say, right? It's a lot easier. So when it's planed down, it's typically about 1/2 inch smaller, right? So 2x4. It's going to be 1.5 inches by 3.5. What was I going to say? I was going to say something I kind of forgot. It kind of left my mind. Anyway, so we plane those things down. We make sure we get the right dimensions. We make sure we get those exact dimensions, and you can kind of count on those things. Oh, I know what I was going to say. When we talk about a 2x4, that is what we call the nominal dimension. Okay, nominal means by name only, right? So in name only, is it a 2x4? So don't go and assume that something, because it's a 2x4, that it's going to be 2x4. This board that I have here, this was from a 1x12. So it's not actually 12 inches wide. These ones actually end up being about 1.25 inches or 11.25 inches wide. So it's not even a true 12 inches wide, because we've surfaced these things on 4 sides. Obviously the end cuts, if this is a long board that extends out, you're going to cut that to whatever length that you want. But the rest of that stuff is going to kind of stay, at the dimensions that are given there. So it's nominal dimension. It's a 2x4 by name only. The actual dimension of a 2x4 is 1.5 by 3.5 inches. Okay. Make a note of that, because I will test you on that stuff. Okay. Understand nominal dimensions versus actual dimensions. To make cuts, there's tools. We have hand saws that we can use. We can use, a little hand saw. We've got a little back saw, which has a rigid back. We've got a coping saw, which is kind of like a hacksaw almost, but this is designed for wood. And you can cut, fine details with that. There's also keyhole saws, which kind of looks like a little gun. That is not, that's a keyhole saw. And you can kind of cut. Typically we use those for like drywall and stuff, but you can use them for wood as well. But these saws, they're all going to do kind of the similar stuff, but the way that we cut and the way that blade is designed on these things is going to determine whether it's a cross cut, meaning we're going to be cutting across the grain, or if it's a rip cut, meaning we're cutting with the grain. Now, ultimately, you could cut a rip cut with a cross cut and vice versa. But what happens is your cut doesn't come out as clean. Okay, so some saws, table saws and things like that, they're a combination, so they can both do rip cuts and cross cuts. Some saws are designed to only do one or the other. We are going to have material that's going to be left when we do cut that's going to be removed. Typically, we kind of factor that as 1/8 of an inch. With especially power tools and things like that, those blades are going to be a little bit thicker. The hand saws that we see in these pictures here, those are typically going to be a little bit thinner. But 1/8 of an inch, is kind of a good standard, that's going to be removed. And we call that the kerf. So that's that open space. If we are cutting a board, is something that we want to make sure of. So like if I made a line, let's say I measured here on this board and I measured all the way to here. Okay. What I would want to do is I'm going to mark my line, and then my blade is going to go on this side of the line. Okay. That's our waste side, because the side that we measured is the side we want to keep. You may use this board for something else, but we're going to remeasure that. We'll cut it. But it's important that when we're cutting, you take your measurement wherever your line is at to make that cut. Let's say if we're going a cross cut here, if that line is right here and this is what you measured, okay, your blade goes on here, and then you just get your blade right up to that edge of your line. You don't want to cut on this side, because then your board's going to be a little bit short. So always, make cuts, on the waist side. Okay. So the side you didn't measure. Typically when we do woodworking, and the videos will kind of explain this too, you make one measurement, you make one cut, right? Don't try to lay everything out. Okay. Because as you make these cuts, that kerf is going to come into play, what's being removed. So it's easy to just make one measurement, make that cut, then measure the next piece, then make the cut. Don't try to account for it either. I see students that do that all the time, where they design everything and it just doesn't come out the same. It's a little bit more tedious for you to do that than just one step at a time, right? One cut, then the next one. As far as crosscut saws go and rip cut saws, this is kind of like an expanded version of kind of what you're seeing. And if you're doing a crosscut, so you're going across the grain, you'll notice these blades are kind of separated out, and we get this little like kind of upside down V right here. As opposed to the rip cut saw, where the blades, one blade's going to be tilted one direction, one's going to be tilted in the other direction. If you ever look closely at a saw, you'll see this on this stuff. And if you see that little V, it's a cross cut. If you don't see that V and you kind of see a flat area, it's a rip cut. And it all has to do with the quality of the cut. Like I said, you can cut with a crosscut saw and make a rip cut, but what's going to happen is that material is going to get torn out of there, and you're going to get a lot of kind of fibers on there, and it's not going to be a real smooth cut. And you're going to have to like sand that and do extra work to kind of get that stuff down. Your accuracy may not be as great because it just kind of will kind of tear that stuff up. So it's important that we're using the right saw. Like I said, table saws, typically they have a combination where they kind of do both. And you can kind of, you don't have to worry about that. But some hand saws and different things, they're going to have the different style blades on there. And you can simply just look down the end and you can kind of tell. what type of cut it is. Cool. Questions with that? I think I'm going to do another one because I don't think this one's that long either. Yeah, it's only a couple slides. So some of the things that you're going to see in here when we're fastening wood together, and you'll see this in that video that you're going to watch next week, is that there are different joints that we can kind of put together. There is a ton of different styles that we can do. A little dado where you basically cut out a thing. We use that on our step stools that we build. We do dovetails. We did those ones on our step stools as well. What's the other one? Where's a mortise and tenon? You'll see that in the bar stool that we made. And it's a pretty cool little process to actually kind of make that. But this one's basically like a little pin that goes into the wood. So you got a hole in the wood, you got a pin, pretty strong joint. Some of these things are kind of there. They're kind of designed to where we don't really need to use a whole lot of fasteners. It's actually kind of fun if you do woodworking to actually build things to where you don't have to use screws and different things. If you cut the wood, you can join them together like puzzle pieces to kind of put these things together. So there's a lot of different joints. I'm not going to worry about all of those. There's just a couple of ones that we really want to focus on. Dados, if you notice on this one, we kind of cut out this board right here. And then the other board just slips right into that. That's great for like shelving, different things that you don't want to move. And it's going to hold that stuff in place, right? You know, if you kind of tilted this thing, if this was tilted upright, you could see that board right there, all the pressure that would be pushing down on this thing is going to transfer into here, and it's going to go down into that bottom. Now, some boards, you might not think boards are very strong, but boards, the force that it would take to collapse this downwards is incredibly strong. Like you would I don't even know what kind of force you would need, but you know, if you took a sledgehammer to that stuff, you would dent that wood, but you wouldn't completely collapse this. Sometimes the boards can break depending on how you cut these things, depending on how that grain's going. Your grain should always go the longest distance. If the grain was going this way and not this long distance here, if it was going this way, it would break very easily. And I think I show you guys that in the video too. So you can actually see that when you watch that video. You'll see what happens with the board if you don't have the grain going the right way. But this board, I mean, it's going to be pretty strong. And so that joint, it's going to hold, if it's a bookshelf that you're making, it's going to hold those books up there, and it's not going to have any problems with that at all, as long as that stays in there. And typically we use like a glue joint to kind of hold them together. Dovetails are a pretty cool one. You'll notice they did kind of two different wood styles on here. Sometimes people do that. They get real fancy. They essentially just cut like this trapezoid out. And then on the other end, they kind of do like the negative space. And these things just basically, they slip in together, and it's a nice joint. It holds together well. There's no need for any kind of fasteners or anything like that. Like I said, typically we just glue that stuff together. And that's typically it. You see it a lot on drawers, boxes, different things, especially if you want to show it off, because these are a lot of work to do. Dovetails are not easy. We do have some tools that will make it quicker, that can actually cut these things out. They have jigs that you can put them together. If you're doing them by hand, they can be pretty tough. The mortise and tenon, you'll see these on like legs, like for like dining room chairs and things like that. Typically they're hidden, so you don't see these things. But essentially we got this board here. We kind of cut out a lot of material, but we left a little pin. And then on the opposite side, on the mortise side, we actually cut a little hole on the inside, and that just basically slips up into there. Pretty strong joint. It joins these things together. Again, we use glue on these things. There's no need for fasteners. We use glue to kind of hold them together. And it's a pretty strong joint that's going to support quite a bit. You do see a rabbet. Sometimes it's a double rabbet or a single rabbet, but this is going to be on like the edge. You might see these on drawers and boxes as well. Not as fancy as a dovetail, but it does get that job done. It does work pretty effectively. We glue those things together, and then it basically holds. Not as strong as a dovetail either, but it's a quicker way to do this. We can take a router, we can take a blade, we can cut here, we can cut down to cut that little L shape out, and then we can join them together. Kind of the same thing on the double rabbet, except there's two of them that are there. Half lap joints, you see these things, on like tables and different stuff like that. Basically, you're cutting out like half of the thickness there, half the thickness on that one, and you put those together. These boards will sit level when you do that. And so like on this one, if you want to make it like a 90 degree, that works really well. You can kind of see it here in this table right here on this end piece where they did a little half lap where they kind of cut out, you know, half that board there and then half of this one, they put it together. And that one, in this example, this kind of helps hold all these different boards together right here on the end. And it joins them. It looks like they got some pins, or those, so I think those are nuts actually. But different ways that you can kind of do that, and you can, you know, join wood together. If we want to remove wood to kind of make some of those joints, like a half lap or something like that, you can see on this example, we're taking a little saw and we're making multiple cuts. So that way there's things are really thin. We take a little chisel and we basically would put it in those joints there, and we move it back and forth. It breaks those things out. And then we can kind of clean it up with a file. You'll see me do that in the video and how we remove that stuff, but just making multiple cuts in between where we want it to go. And then we can join those boards together, use some glue on there, and it's going to be strong. Glue is one of those things that a lot of people think is not that strong, but the glue in most wood glues is actually stronger than the boards themselves. And so if you got a nice surface, you've got a good joint there, that glue is going to help hold that stuff together, and it's not going to come apart. It's going to break somewhere else. We do have a little cheater device here. We actually don't have one at the school, but I have one at home because I like doing woodworking. It's fun. But if you want to make like a nice flat tabletop and it needs to be pretty wide, you can simply take this little biscuit joiner, and these are little biscuits. We don't eat them. They're not like biscuits and gravy. Okay. They're little wood particles that have been glued together and kind of pressed together. And we take this little biscuit joiner, which basically just kind of cuts this little notch out. And then those biscuits are able to kind of just slip into there. We put some glue together and we can line those boards up. It's a nice flat surface. It joins them together as opposed to just taking two flat ends and then just pushing them together. It gives a little bit of strength. So if you want to do like a tabletop and things like that, biscuit joiner is a pretty good way, and it's hidden. You don't see these things, you know, from the top or the bottom. Okay. You don't have to have anything else there. It's just going to join them together. But that's kind of the importance of having that wood, make sure it's dried out, because if you try to glue these things together, and let's say you glue them together and then that wood dries out, you're going to get a ton of cupping where it's going to go up or it's going to go down, because wood is just naturally going to do that. It's going to have that cupping. You might see dowel joints, things like that, if you ever put like furniture together. And that's where we basically drill a hole, we put a dowel on the inside and we join them together. You know, so a lot of prefab furniture, you'll see that stuff with, because it's easier for them just to kind of do that. It doesn't take very much. They can have it all there. They give you the bag of the little dowels already cut to length, and you just slip those pieces in. It's strong, it's effective. It may not be the cleanest, it may not be the prettiest way to kind of do it, but it does work pretty well. And that's why you see it a lot on like furniture stuff. Again, the best way to do this is to kind of glue it together. You may have a clamp on here that kind of holds this together while that glue is drying. Typically takes about 30 minutes for wood glue to kind of set. And so you may have clamps, and really kind of with the other joints too, you may kind of clamp things down while that glue is setting, because otherwise it may move or shift on you to kind of hold them in place. But this can be done very easily. This is a joint that really doesn't take a lot of fancy tooling. All you really need is a drill bit. You can drill a hole, you can get a wooden dowel, you can cut that dowel to whatever length you want, and then you basically just slip it in. So it's a very easy one to kind of make. And they do have jigs, Craig jigs. They make stuff where you can actually, you know, cut these little dowel holes out and make life a little bit easier to kind of put things together. And this is kind of an example of, you know, one of those little things that we would do. A lot of times like cabinet doors for like kitchens, you know, kind of frames and, you know, picture frames and stuff like that. Craig jig has a little jig that you clamp on. It allows this to drill at an angle, and then we put a little screw in there. And this is like a hidden screw. They have wood that you can actually put over the top of this thing. You could sand it down to where it's flush, flat. You can match that wood type to it, and you'll never know that there was actually hardware in there. Sometimes when we're doing woodworking, we don't like to see that hardware. We don't want that, right? Woodworkers, they like to kind of take pride in craftsmanship and stuff like that. And this is kind of a way to cheat that system to get a good, you know, a good frame that's got a nice tight joint, but then you don't see, you know, that stuff on the backside. Typically you'd put these on the backside, not the front. So if it's a picture frame, right, where it's hanging against a wall, this would sit up against a wall, and you don't have to fill those in, but if you wanted to, you absolutely could. When we are drilling holes, we use countersinks. Okay. If we were to just drill a straight hole and then put a wood screw in, you notice how the head is right here. The way that that head sits, if you were to sink this down farther, it's going to put pressure on this board and you're going to split a board across. And so what we do is we drill a hole, we use a countersink that kind of, matches the shape of that head and allows us to push that thing in without putting pressure on that board and causing it to split. You do have to, if you're screwing, you do have to pre-drill holes. Otherwise, boards are going to split, okay, especially if they're real dry. So you can do a 2 combination, or you can buy one that has the drill bit and the little countersink head in it. And you can see there's different sizes for different size screws, and we can kind of push those things down. So if you aren't just doing joints, you can do a little countersink, which is going to drop that stuff down and just kind of remove that material. It's important that we remove some of it. We don't want all of it. Obviously, we want the threads to be able to grab into that wood. So the bits are a little bit smaller for the size of the screw that we're doing. And the head size is obviously going to change as the screw gets bigger. So the countersinks are going to be a little bit different. I don't really prefer this method here. I prefer buying these things. Typically, if you go to like Home Depot, you buy them. It's a set of like 4 of them. So you might get like these 4 right here in a set. So you have a couple different ones that you can choose from depending on what screw you're putting in. Another way we can kind of do like a hidden fastener, and typically you see like these finishing nails on like railings and things like that. It's a very tiny nail, a very tiny head on the nail. We actually drive it in with a hammer. We take this little thing called a nail set, which just kind of comes to a point. It has like a kind of a concaved, look on the end of it. And it sits on the end of this head, and then you just hit this thing down, and then it should be recessed below that surface. Very, very tiny. You don't see these things unless you're really looking for them. So again, it's a way for us to kind of hide that. You see this a lot on railings. They kind of go and they kind of toenail it into the side. So they might put 2 of them on the very bottom, 2 of them into the top. Okay, so that way you're not seeing this hardware, you're not seeing all this stuff, but you're getting those things secured. Sometimes you can't put a screw in through the top, or you don't want to screw in through the top, or you can't put it up through the bottom. And so these finishing nails are a good way to kind of hold that railing in place. Now, a lot of these joints, we're obviously going to use glue. I've mentioned that a bunch of times. When you're gluing things together, you want to make sure that you have enough glue to where it's going to squeeze it out of that joint. Like you can see right here, there's not any gaps like you have right here. That means there's too little glue. That means anywhere like in this section, and that section, and this section, that means it didn't actually fill up that whole joint, and that's going to be your weak spots. We would rather than this, we would rather have too much glue, but this is a lot of extra work to kind of clean up. Glue does get on the surface. If you like wipe it down here, it'll basically just kind of cover that surface. If you try to stain it, it's not going to stain very well. So you have to sand that stuff down. If we had something like this, where we had too much glue in here, and even if we have this one, how it kind of squeezes out, what I typically do is just let that stuff dry in place. And then I just take a putty knife and it scrapes right off. And then the only spot where there's glue is right in that joint, right where that joint's at. But we typically don't like to smear this stuff with like a rag because it will just it will block stains and it'll make things look kind of funky. But you want to make sure you put enough glue to where it's going to come out of that whole joint and try not to get too much like this. But we would prefer this versus that, because this is just the issue with this is because glue is not expensive, but the issue is just the cleanup process with this. It's going to be a lot harder to clean this stuff up. But at least on this one, it's going to hold. It's going to maintain, that strength that we have with that stuff. Cool. All right. That's the last part of that. I know I ran through those things pretty quickly, but they aren't too long. Do you guys have any questions on that stuff? Did I bore you guys? Did I put you guys to sleep? Oh my gosh. I hope I didn't do that. Maybe I did. Maybe I'm not.
No, you didn't.
All right. Okay, so that's all I'm going to go over today, with you guys. I wanted to get those things down because those videos that you're going to have, I will post those things beginning of next week. So you guys will have next week to watch them. There's going to be 2 safety videos, one on hand tools, one on like power tools. And there'll be like a little quiz with that, like a little safety type quiz. But again, you'll be able to take it as many times as you want. Okay. take it multiple times to get, the full credit on that stuff. So those ones are going to go over the safety tools, or the safety things we got to kind of focus on. And then there's a 2-part video on building the bar stool. Those things will be posted in Canvas as well. Watch those things, and there's going to be a quiz that goes along with that. You can pull the quiz up while you're watching it and answer the questions as you go along, but you will have that. You can answer those things as many times as possible as you want, to try to get that full credit on that stuff. You'll see that process. You'll see these tools. You'll see them in action, and I explain them. The only thing that I will say is that the audio is not necessarily the greatest, because I was just kind of figuring out how to make videos, and I didn't have fancy mics like I do now. I apologize about the audio in advance, but it should work. A lot of it, I kind of dubbed over it. And so, a lot of it's pretty good, but there might be some spots where it's not, excuse me, where it's not the greatest. So, but we'll kind of watch those things. And then the last thing, I just want to remind you guys, if we can, next week is going to be a good week for us to pick up the materials, because the following week after that, on the 19th and the 20th, that's when we're going to be doing, I don't know if I'm going to do the plumbing or the electrical first, but we need the materials that you're going to be picking up. So try to get it next week if you can. If not, the following week, we can get it. We have up until, Wednesday, I guess, maybe even Thursday if you're close by. But let's not wait till the last minute to try to pick these things up. And then if you can't pick it up, if you can't do that, shoot me an email, let me know, or you can kind of talk to some of the people, that are in this class, and try to get that stuff organized to where maybe one person can come and pick it up for other people if you guys are close. So if you guys don't have any questions, you guys are free to go, and I will see you next week, or maybe even in person. So.
Bye.